Okay, so after we use the matrices to find the vertices, well, don't forget this was the vertex A, B, C, and D. So these are my new vertex, my new vertices for A, B, C, and D after my translation. So we then call this A prime, B prime, C prime, and D prime, which would make A prime 6, -2. B prime would be 5, 2. C prime would be 2, 0. And D prime would be 2, -2. Okay? So what would that look like here? Well, let's see. Let's plot these points and see if we really do get the same, we do get that translation. So we have A prime, which is 6, -2. That would be 6, -2 down here. This would be A prime. We get B prime, which is 5, 2. So it'll be 5, 2. This is B prime. We get C prime, which is 2, 0. Let me move this up. 2, 0, that's here. So this is C prime. And then we have D prime, which is 2, -2. That's D prime. If I connect these vertices, notice I get a translation. The figure, the shape, the size does not change, but it is in fact translated 6 units to the right, 2 units down. I can see that. Let's just do B prime because it's the highest one up. I'm moving it 1, 2, 3, 4, 5, 6 units to the right, 2 units down. And I can assume the same with the other vertices because the size or shape did not change. So the way you basically translate a figure is using matrix multiplication. Don't forget you have the vertices of the quadrilateral matrix. I should put matrix here. So you have that matrix with the x and the y represented in the first and second row respectively. The translation matrix, you repeat whatever the translation is. So whether it's moving up or right, whether it moves left or right, it goes on the first row for my x coordinate. Whether it's moving up or down, it goes in my second row. If it goes up, it's positive. If it goes down, it's negative. If this goes to the left, it's negative. To the right, it's positive. Okay. So we're going to move on to the last type of transformation for the day, which is dilation. It's a transformation changing the size of a figure. Whenever you're using your phone or your tablet and you zoom in, what you're doing is you're dilating the image, okay? You're increasing it, you're stretching it, or you're shrinking it from a certain position, which is the same type of transformation with the figures we're going to do. I'm going to do example 2. I can't do the real world problem because it involves... Sorry about that. It involves the stretching of a image of a tiger, which I am not going to draw, but I can show you with some points that I made up here. Okay, so we have A2, 2. We have a triangle. Let me just read it. We have a triangle ABC that's dilated by a factor of 2. It means it's being zoomed in so that it's twice as big. Whenever we zoom in, it's always done from the origin. Okay. Meaning our point of reference, let's say this is our triangle, right? We have A, B, and C with these points here. What we're basically doing is, imagine if this were a phone screen. When we say from the origin, we mean if one finger were here and we were stretching it out from this point of the origin, okay? How do we do a dilation using matrices? Well, we're going to start off again by doing my matrix of the vertices. So considering these points, it's going to look as follows: 2, 2, 2, 4, 4, 3. And what we do is scalar multiplication. That's what we do for a dilation. Okay? What are we multiplying this by? Well, whatever factor it's being dilated by. It's being dilated by a factor of 2. So I'm going to be multiplying by 2. Okay? And you guys know how to do a scalar multiplication. I'm just multiplying every term in this matrix, every element in the matrix by the scalar. So we're going to get everything multiplied by 2. So we're going to have here 4, 4, 8, 4, 8, 6. This is now telling me my elements here are now telling me my vertices of my image. So it's going to be A prime is going to be 4, 4. B prime is going to be 4, 8. And C prime is going to be 8, 6. Okay? So let's graph that really quickly so I can see what it looks like. 4, 4 is going to be somewhere. It's going to be here. This is A prime. I should expect my triangle to look bigger because it was dilated. It was stretched out. B prime is going to be 4, 8. That's up here. This is B prime. And C prime is going to be 8, 6. And we do notice in our image, this is my image, this is my pre-image. I don't know if you're able to notice that in my image, my triangle did get bigger. It is about twice as big, okay? And the reason it looks like it's translated is because, remember, I'm stretching this out starting from the origin. So if I were to zoom this out, it might look like it's translated, but it's really just a dilation, okay? So one important thing to know with dilations is that, remember, earlier I said it is a stretch or a shrink. What determines whether it's being stretched or shrunk? Well, if your scalar, let's call this C, my scalar. If my scalar is bigger than 1, like our number 2 here is bigger than 1, then it is a stretch. Right? You're making it bigger. If my scalar is a fraction, meaning it's between 0 and 1, so it's less than 1 but it's greater than 0, it's a fraction or decimal between 0 and 1, it is a shrink. So if I were to have multiplied the same matrix by 1/2, it would have been a shrink.